Hello children, my name is Anand Kumar Tiwari and I am PGT Mathematics in Kendriya Vidyalaya 1 Stacy, Jabalpur. I have come before you to solve and discuss about class 12th chapter 1 relations and functions, and to discuss and solve the problems we have used a digital medium. So I hope that you will enjoy it, and let us begin the chapter. Relations and function. This chapter we already studied in class 11th, but that was a brief part, introductory part. The important and the basic, the more detailed part we will study in class 12. First of all, I will brief you about class 11, what we studied in class 11. Let's have a recap of it. For that, we take a set. I'm starting with basics. Let us take a set of 1 and 2 only. Now we used to find out its a Cartesian product, that is 1 comma 2 is multiplied to 1 comma 2, and then we get ordered pair 1 comma 1, then 1 comma 2, then 2 comma 1, and then finally 2 comma 2. Hope this one is clear to all of you. This is our A cross A. Now we define a relation which is subset of A cross A, relation which is defined on set A. So when we say defined on set A, that means it is subset of A cross A. So we define relation R on set A under some conditions. Remember, relation, since relation is a subset of A cross A, so it will be containing ordered pair, as we have studied. Condition is that x is greater than equals to y. This is what we studied in class 11. We are recapping. This is known as our set builder form, where we write the elements in the form of formula or rule. Now, under this condition, we collect the elements from A cross A. Condition is what? X is greater than equals to y. That means the first element equals to second or greater than the second. So let us first collect. This is there, which is satisfying the condition. 1 comma 1 is there. Then next is 2 comma 2 is there, because both of them are equal. And the next is the first is greater than the second is this one. This we got it. So that's how we got relation. Now we used to get domain of relation. Under domain of relation, we used to write the first elements of these ordered pairs. So first element is 1 and 2. Repetition is not allowed in a set. So 1 comma 2 is there. And likewise we get range, that means the collection of all the second elements. So that is again 1 comma 2. Right, this way we used to study, or this is what we studied in class 11. Now we come to class 12, the basics of class 12 that we have to study. We start with types of relations. Types of relations. This is the basic of class 12. The starting of class 12 of this chapter is this. So very first type I will discuss with you is empty relation. Empty relation. As the name is there, empty relation, it means it does not contain any ordered pair which is satisfying a condition. For example, I take a set of x comma y, and the condition we apply that x square plus y square is less than 0, and this is the relation. We define relation conditions that x comma containing x comma y subject to this condition, and x and y both are real numbers. So can we find out any two real numbers sum of squares of whose is less than 0? हमें क्या कोई भी दो रियल नंबर्स ऐसे मिलेंगे जिनके स्क्वायर का सम 0 से छोटा हो? ऑब्वियसली नॉट. कोई भी दो रियल नंबर्स ऐसे नहीं जिनके स्क्वायर का सम 0 से छोटा हो. So none of the pair is there which is satisfying this condition. So we will say that this relation is actually empty relation, also called void relation. Opposite to that, if I say that take an example, a set of A containing 1 comma 2, and on this set we define a relation R in a set builder form subject to the condition that x square plus y square is greater than 0. X square plus y square greater than 0. So, and relation is defined. Do remember, relation is defined on set A. So, it is quite clear that all the elements of this set A will satisfy this condition. They are real numbers, and real numbers squares, particularly these real numbers. So, what we find out that sum of the squares will be greater than 0. So, this way we can say that this relation is actually equals to A cross A. And whenever a relation is equals to the Cartesian product of the sets on which it is defined, such type of relation is known as universal relation. So this is universal relation. I have continued with empty relation, but this one is your universal relation. Here I write down universal relation. This is type 2, sorry. This is type 2, this is your type 1. Hope it is clear. Universal relation satisfies all the ordered pairs, or all the ordered pairs of A cross A satisfy the condition. This is universal relation. So far we have studied two types of relations. One is empty, the other one is a universal relation. Now we come to more important part, that is reflexive relation. Reflexive relations. Reflexive relation, as the name suggests itself, when an element is related to itself, or say an example, take an example that every element is equal to itself. Every element is equals to itself. So here equality is a reflexive relation. Likewise, every triangle is congruent to itself. So here congruency is reflexive. Reflexive relation means that when an element is related to itself by a relation, and that relation should be logically acceptable. It is not that is simply we are saying that an element is related to itself by any relation, any arbitrary relation. It is not possible. It is not always possible. Like we say a line is parallel to itself. So parallelism is reflexive relation. But if I say that a line is perpendicular to itself, that is not acceptable. So it implies that every relation is not reflexive. That is the meaning. So reflexive relation is that one in which each element is related to itself. So here every line is parallel to itself. Here reflexive relation. Parallelism is a reflexive relation. Every triangle is congruent to itself. So congruency is reflexive relation. Every number is equal to itself. Equality is a reflexive relation. That is the meaning. Now I come to reflexive relation on a set. Take a set A of 1, 2, 3, and now we define reflexive relation on this set. So when we define a reflexive relation on a set, it means, as we defined earlier, that each element of this set is related to itself, which means 1 is related to itself, that is 1, 2 is related to itself, that is 2, 3 is related to itself, that is 3. And this condition compulsorily holds for all elements. That means if 3 comma 3 is not there, these two are there, but 3 comma 3 is not there, so we will say that this is not the reflexive relation on this set A. Apart from that, other elements of this set can be there, still it will be a reflexive relation. This you can understand, this putting other additional elements, making it reflexive. This concept you simply understand that when you see some objects, suppose you have taken 3 pens and you see their reflections, so in mirror, so you can see the images of all the three. Apart from that, some other things which are in the room, that will also be reflected in the room, so still it will be a reflexive relation. Hope this concept is clear. So in general, in common, whenever a relation is reflexive, then it contains this kind of elements, or this is also written as A related to itself. That is in general, in common. So when we are going to solve numericals, there we will use this concept. Hope it is clear. Next is a symmetric relation. Next type is symmetric relation. Symmetric relation. Now, symmetric relation, for symmetric, two things are required. That means if a thing is related to another thing in one way, and the other thing is related to the first thing in the same way, then we say the relation is symmetric. One thing is related to the second thing in some way, and the second thing is related to the first thing in the same way, then we say the relation is symmetric. For example, if A is neighbor of B, then B is also neighbor of A. So neighborhood is symmetric relation. If a line is parallel to second line, then it is quite obvious that second line is parallel to first line. That is a symmetric relation. A line, say L, is parallel to M. So since it is parallel to M, so M is parallel to L. Other way also it is true. If A is a brother of B, then can we say that B is brother of A? Not necessarily. B can be sister of A also. So logically we have to think, arguably we have to think whether the concept in the reverse way holds or not. That is called symmetric relation. Like a line is perpendicular to another line. See the diagram. Line L, line M. L is perpendicular to M, and M is also perpendicular to L. So perpendicularity is a symmetric relation. Hope the concept is clear. Now, symmetric relation on a set we go for, say, uh, take the same set as we have been taking from the beginning. Set A is there, elements are 1, 2. On this set, we are uh, writing a symmetric relation. So, as I defined that if 1 is related to 2, 1, 2 is in R, it means 1 is related to 2, and 2 is also related to 1. That means 2, 1 is in R. Then we say that this relation is a symmetric relation. Suppose we define one more relation. This is R1. R1 is defined on set A and R2 is also defined on set A. Suppose one had it been, suppose, say, we extend the set, that will be making the things easier. 1 is related to 3 and 3 is related to 1 and 2 is related to 3, but its reverse pair, the reverse ordered pair, is not there in R2, so this relation will not be symmetric. Keep it in mind. So this is symmetric relation. Now next comes transitive relation. Transitive relation. Transitive relation, as we started with a reflexive relation and then symmetric and now coming to transitive. In reflexive relation, we said that each element is related to itself, or one element is related to itself. In symmetric, we said that if one is related to another element, then the other is related to the first element. That is symmetric. Now we are going to transitive, so here we need three elements. This we can understand by a common concept that suppose A and B are two persons living in a same society, and B and C are also living in the same society or same locality. Then it is quite obvious that A and C are living in the same locality. So here, living in the same locality or same locality concept is transitive. Take easier example. A equals to B and B equals to C. Then it is obvious or logically we can accept that A equals to C. So here equality is transitive relation. Now a line is parallel to second line is parallel to third line. Draw the diagram. Line 1 parallel to second line. Line 2 is parallel to line 3. I am talking about 2D. Line 2 is parallel to line 3. Then it is true that line 1 is parallel to line 3. So parallelism is transitive relation. Likewise, we have congruency, similarity, and some other relations. That is what the meaning of transitive relation. Now we come to transitive relation on a set. We take a set of 1, 2, 3. On this, we try to define transitive relation. Talking about transitive relation. Say 1 is related to 2, 2 is related to 3, 1 is related to 2, 2 is related to 3 by a relation, and If 1 is also related to 3 by the same relation, then we say that this relation is transitive. So that we have to check whether the third pair is there or not.